Welcome to the demonstration of Use Case 2 for the Astrid Security Framework. In this video, we are going to deploy 3 services via the Astrid Security Dashboard and demonstrate the security enrichment of these services using the examples of a firewalling service and a machine learning-based attack detection service. The 3 services we are going to deploy are the components of the evolved packet core to exemplify a 5G mobile network edge deployment, the components of a remote patient monitoring application and a vulnerable NTP server to act as our victim service to demonstrate the Astrid machine learning-based attack detection. First, we are going to upload the service description file for the 5G mobile network and deploy the service via Kubernetes, which is one of the supported orchestrators. As you can see from the log message, the deployment has been scheduled. We can verify the deployment via the command line on our Kubernetes cluster. Next, we are going to deploy the remaining services and verify their deployment too. For the 5G deployment, we are going to enable the firewalling service and configure it first with a deny all policy, which blocks all ingress and egress communication. To verify the successful configuration and enforcement of this policies, we are trying to establish a connection from the mobility management entity to the home subscriber service. For this purpose, inside the mobility management entity container, we look up the IP endpoint of the home subscriber service and try to establish the connection via netcat. As you can see, we are not able to connect as the connection times out. This is possible, because in the background after deployment and again after configuration of the policy, the relevant information has been submitted from the dashboard to the Astrid context broker and passed on to the Astrid security controller. The data is stored in the Elasticsearch engine and it is possible to use the REST APIs of the context broker manager, in this case a GET request, to list all of the services deployed with the Astrid dashboard and managed as an execution environment by the Context Broker Manager. Each service is identified by its ID and has some properties: IP address, host name and deployment type used. To get the firewall rules currently installed, for example in the 5G policy and charging rules function execution environment, the Context Broker Manager accepts a put request to perform a specific action. In this way, the local control plane, after the execution of the action, returns the result. Now we are reconfiguring the firewall to allow the necessary communication between the 5G network components, specifically the connection from the mobility management entity to the home subscriber service. Here we see 2 terminals, one for the security controller output logs, and one for the Veracube. We can see that the reachability policy is received by the security controller that was provided by the dashboard. At this point, the security controller contacts the context broker with a GET request. Here it obtains the information about services deployed with the Astrid dashboard and managed as an execution environment by the Context Broker Manager and the Elasticsearch. It retrieves information about each service using the ID described in the reachability policy information. This includes IP address, host name and deployment type used. At this point, the security controller delivers the infrastructure information and reachability policy to the Veracube. Veracube automatically generates low-level firewall configuration parameters. Here we can see the output at glance, where each firewall component now contains 5 tuple firewall rules. This information now is delivered to the context broker with a put request. After the insertion of the firewall rules, we can make a put request to the Context Broker Manager API again, which shows the list of the updated firewall rules currently installed, for example in the 5G policy and charging rules function execution environment. To verify the successful updated of the firewall configuration and enforcement of this policies, we are trying again to establish a connection from the mobility management entity to the home subscriber service. This time the connection can be successfully established and the two services can communicate. For the NTP deployment, we are going to enable the machine learning-based attack detection service and demonstrate the attack detection capabilities. With TCP replay, we will reenact the traffic flows from a 2017 simulated distributed denial of service attack utilizing the low-orbit ion cannon application. Here you can see the running machine learning deployment. It is extracting the features from the data streams produced by the Kafka channel, which will be examined by a random forest machine learning model. If an attack is detected, the machine learning deployment sends the 5-tuple information of the traffic flow in a separate Kafka channel. The security controller reacts to the output of the machine learning module listening to the Kafka bus. We can see that it received 100 distributed denial of service attack messages in a certain time slot for the specified source and destination nodes. At this point, the security controller itself generates the low-level configuration parameter to block this attack and pushes the automatically generated firewall rules directly to the context broker. In the security dashboard we can see 3 generated alarm messages. After the third message, the automatically generated firewall rule takes effect and the attack has been mitigated. This concludes our demonstration. Thank you for watching and goodbye.